Parmar, along with Bhumik Rathod, stand before you to share about enhancing the properties of in FRP using graphene and MWCNT under the guidance of Dr. Partha Berry, Atira and Professor Vishwesh Badeka, PDEU. So before straight jumping into the things we covered in Atira as a 2-month internship program, sorry for this. So I would like to express my heartfelt gratitude to CINCE, Atira and PDEU and the organizers, Ahmedabad University, for this opportunity to share our work done at Atira for 2 months internship. And this is a fruitful outcome of the MOU signed between PDEU and Atira on 15th of September 2023. And an MOU signed between PDEU and CECA on 23rd May 2024. So our motivation is to use graphene and MWCNT in FRP, that how can we change the properties electrical, mechanical and chemical in that, and how we can use this in different weight percentage to find what is the exact weight percentage or the amount of nanomaterials to be infused into the FRPs. And this is the outline that will know what is Atira and what is FRP, its application, challenges, and how nanomaterials can be used in it, and why we use graphene and MWCNT, types of manufacturing processes, and why we use vacuum infusion only, and the future application challenges, and finally we'll conclude. So, established as a non-profit research association to address challenges faced in the textile industries, established by Mr. Kasturbhai Lalbhai and Dr. Vikram Sarabhai, father of space program, in the same year as we got independence in 1947, till now Atira is working on skill development programs and enhancing everything, every sector that textile deals with. So as we are from the chemical background, it's like we can't cook a meal without knowing the recipe, and this was our recipe, that what is FRP. We first should know that what are FRP and a little bit about the textile domain. So for FRP, it is the fiber reinforced composite, where fiber provides the strength and stiffness, and polymer matrix acts as binder and stress distributor, and due to its lightweight strength, design versatility and corrosion resistance, FRP is used in various sectors. That is, first is the aerospace, electronics, constructions, marine, wind energy and automotive. Yet it is very useful. It has some of the drawbacks, that is heat buildup. So if we are using in the electronics, then we can't use it, because if the heat is building up, then there may be chances of fire, it may catch fire. So it is an insulator, so we have to make it conductive in the case of electronics, and its durability concerns thermal recycling and fire resistance. So there comes the nanomaterials, where the nano dimension is the key, that at least one of the scale should be in 1 to 100 nanometers, and its diverse application and enhanced properties helps to use them. So we used graphene and MWCNT just because it has a higher thermal conductivity of 5300 watt per meter Kelvin at room temperature, and high strength to weight ratio, and it is due to the honeycomb lattice of a graphene. So if we talk about graphene, there is a hexagonal lattice where the electrons are moving. Electrons are free because of 3 covalent bond and 1 dislocated pi electron. So that's why electricity is easy to conduct, because it is the flow of electrons. And in MWCNT, it has a high aspect ratio, that is the length to diameter ratio, and also the excellent thermal conductivity of 2000 to 6000 watt per meter Kelvin. And we are aware that nanomaterials have the highest surface area than any of them. Here it has 5000 meter square per gram, for 6 nanometer diameter and 3 volt nanotubes. So it's a comparison table that we can see for graphite, copper, carbon black, nano-size steel. Among them, graphene and CNTs are dominating, and that's why we used these two materials as our project. Same goes for the electrical conductivity and tensile strength. So as I discussed that what should be the what should be the weight percentage to increase the thermal conductivity up to that mark. Hence we use different types of weight percentage to perform the experiments and then test that what is that level, that is percolation threshold up to which the electrical conductivity or thermal conductivity is going to be rise. After that there will be a plateau, then it can go down or it remains the same. So key points to consider are achieving good dispersion, no agglomeration. Here you can see if the agglomeration takes place or there is a void or no low dispersion, then the conductivity will break down. So we have to give a good amount of dispersion time. Here at Atira we performed the experiments and we kept it for 18 hours dispersion and then find the composite. About the glass transition temperature, that is, it is only for the amorphous polymer. Pure crystalline does not have Tg, it only have the melting point. And below Tg it is brittle, and above Tg it becomes glassy and viscous. So for applications of at high temperature we have to increase the Tg. So by using graphene we can increase the Tg, and for that we have to conduct the TGA test, that is thermal gravimetric analysis. And application of graphene and MWCNT based nanocomposite, that is the first is heat dissipation that I talked in electronics, and thermal management in buildings, insulation, just like PCM, phase change material. We use it for if sun rays fall onto the wall and we don't want to heat up the room, we use the PCM at the walls, at the radiation. And on thermal energy harvesting, that is if it is a pyroelectric component, then we can make it as harvesting for it. And then the types of FRP processes, I'm sure that everyone is aware about this, because for us as a chemical engineer we have to know that what are the processes and out of it we can use this. And we use the vacuum infusion processes, which because of the high fiber content, consistent quality and improved properties, cleaner processes and less resin usage. But it has a disadvantage also, that is its initial cost is high, requires skill experience, because if there are no skill experienced people, then the composite material and the manufactured sample will be wasted, and it has a limited resin viscosity range, and due to that our sample failed and will be discussed further, and limited certain parts and size and shape. So this is the overview of a vacuum infusion process, where we have to prepare a mold and then put the glass fiber, then peel ply and stage, and then we'll insert the resin. And this is the data set of our sample that we used ARL 135 and AH422 and graphene and MWCNT in different weight percentage, and further Bhumik will continue.
So first of all, good morning everyone. As Preeti discussed, so I will start on from vacuum infusion process. So basically vacuum infusion process is mold preparation. So first of all there will be a glass plate. On that glass plate you will apply a silicone spray, so that at the end of the process when you are removing the particular sample, it won't stick to that particular glass plate. After implementing the glass plate, there will be 12 layers of the glass fiber which we will be using in the particular sample development. Then there will be a peel ply. Why we are using the peel ply? So at the end of the removal of the particular sample, it won't stick to that and it won't break. That is the big advantage of using a peel ply. And then we are also using a release film to prevent the composite material to being sticky. Sticking it to the particular glass, and then we are also using a mesh size. So when during the infusion process, when the resin is being implemented from a input input. So the particular, due to the mesh size, the resin will spread on to a particular area which we have decided according to the calculations. And next, these are the samples which we have carried out. ARL 135, it is epoxy resin. So there is also one of the disadvantage. Before you jump into epoxy resin, there are many kind of epoxy resin. I will mention that. First of all, epoxy resin we have used over here is bisphenol A. So why we are using bisphenol A? As many of them have come over here, so I will discuss why we are using bisphenol A and why we are not using polyester resins, phenolic resins. So polyester resins, its mechanical strength and compared to bisphenol A, it has high fire resistance, but mechanical strength is very low. So we can't use polyester resin. And phenolic resin has high fire resistance, but we can't use phenolic resin because after a certain period of time its lifespan is being reduced, and it is due to the polymer chain, the polymer matrix. In the epoxy resin there are three kinds of chain: the first degree epoxy resin, second degree epoxy resin, and third degree epoxy resin. So 3 degree epoxy resin will have 3 molecules which bind with the particular polymer matrix, so that it will make such a bond which will be very much stronger. So that efficient bonding is being done with carbon, multiple carbon nanotubes and graphene. So that is the reason we are using bisphenol A. Moving on to the next one, these are our sample preparations which we carried out. So as you can see over here, this is our pure resin which has been mixed with the hardener. So hardener is cycloaliphatic amines which we used over here, and this is for graphene. So while also we have to take, as sir has mentioned, that we have to train the professionals. So while handling the graphene is very lightweight. While opening the packet also, half of the graphene is being introduced into the atmosphere, which can lead into your lungs, which can also lead to some breathing problems. So while handling the graphene, you have to wear mask and all. And this is the resin resin mixture which we spread onto the silicone mold to prepare our sample. And this is the vacuum infusion setup which we have been created. As you can see, the first one is, as I have talked earlier, this is our first setup, and the final product is that one, the graphene fiber reinforced polymer matrix. So that is our sample which has been successful, and this is our sample which has been failed. And why it has been failed? Because we have used a higher amount of graphene. So you also have to calculate that how much amount of graphene is to be used, and it has to be mixed with our resin as well as hardener. And as you can see, our first sample, you can see that there are bubbles. So while after preparing the mixture, you have to keep the particular sample for 24 hours mixing. After mixing, you have to keep it at an RPM of about 400 to 500 RPM. Beyond that, the particular sample can lead to bubble formation, and to remove that bubble formation, you have to do the degassing process, where the particular sample is being kept into a degassing, where the bubbles have been broken down at a higher temperature. And these are our successful samples, the second one and third one, and these are our weight percentage. Over here, I will just take few minutes. Over here, 0.5% is our base, and calculating on that particular thing, we have taken 1 gram. Similarly for the rest of the samples. These are graphing samples. And after the completion of our samples, we carried out certain tests. So this is the tensile test which we have carried out at Atira only. So you can see our sample over here. So basically, these 3 lines are the different colored lines. The first sample shows the green color line. So you can see the thickness of our sample with maximum load. The maximum load is 2.84 kilonewton. So beyond that, the particular sample will break down. And also the extension period, how much the particular sample can take on the stress and how much it can extend. So that is basically, and Young's modulus also you'll be knowing that that in aerospace engineering, the particular designing is being made up of aluminum. You all be knowing that, and also alloys of aluminum. So that particular aluminum has a GPA of around 0.8 to 0.9, and you can see over here that the GPA, the Young's modulus value is higher than that. So that is the benefit, one of the major benefits. So that is the reason we can use this in the aerospace industries also. And similarly, the fractional chain, that while sample, you can see over here the sample which is been placed over here, how much bending strength it has. So that is the fractional test which we have conducted at Atira only. So this is basically, and this is how we also come to know on the basic certain tests which have been conducted at Atira. The facilities are also very much good over there. So I will also request the young researchers also to attend the internship over there. And we will also like to thank Dr. Vishwesh Badekia for providing us this opportunity at Atira. I will also like to thank Dr. R.K. Singh for inviting us over and presenting our presentation over here. So thank you.
Good morning, one and all present here, including uh, industry experts and speakers. I would like to thank Dr. R.K. Singh for being in this conference, and also Dr. Vadeka sir for encouraging us to present our internship proposal here. So this present is a brief overview of what we have been through at Atira, where Dr. Ankush guided us throughout the project of agriculture drone, which was carried out by myself, Krishna Vishnu, and my colleague Pawan, with one more colleague, Jainesh Singh Sonar. So, as discussed earlier, the MOU signed with Atera, I would like to. So, the motivation behind our project and the project given by Ankush sir, it was when companies like CCA and also Atera joined PDPU. It helped us in encouraging and boost our confidence uh, in the field of mechanical related to composite department. Our main aim was just to elaborate what the companies or the research centers related to composite does with the materials in the agriculture sectors. So this is the outline as discussed earlier about the Atira by Priti and Bhomik. The theory of practical composite manufacturing processes, project, executive, summary, components, and methodology we applied during a project of agriculture drone. And the design and analysis of drone and difference of the quadcopters and other designs which we consider, such as octocopters and coaxial hexacopters. Uh, the future scope of our design, which we have created, and the conclusion. So already Atera has been introduced a lot of times in this conference. I would theory of practical in internship of in our internship we learn many processes like handling of vacuum infusion bagging and other processes. So the processes are already discussed. So moving further to the project, my colleague Paul will continue.
The project was given at Adira to make develop and designing or project that drone design, agriculture drone design that have a 25 kg payload capacity, and the project is used for the pesticide spraying or the liquid spraying for the crop growth and safety for crop. And now considering the drone in India, that have 3,000 drones, they being utilized for the agriculture sector. And now to the February 2025, that are expected to 7,000 drone has utilized. That are the main major components for of the drone: arm, central frame, mounting stand, power system, motor, propeller, software. Arm, central frame, and mounting stand. They are the manufactured at Atira, and some electrical component we get through the market. Uh, they are the methodology for the full design and develop for the drone. First, we research the drone, which type is drone is available, which how many types of drone. We consider many type like octocopter, hexacopter, quadcopter, and coaxial copters. Then we choose the coaxial quadcopter, and now we start to develop a design and a dimension, and that after we calculating some mathematical calculation for the drone flying, how much time is taken, how much weight, then we analyze the drone body, that how much load is sustained, and then some after result we update the design, and then we make a final design. A technical gap. Now the major problem in this agriculture drone is the flight time. Flight time normal has is 12 to 15 minutes in agriculture drone. After this time, after this flight time, we need to change the battery or the recharge by battery. Battery recharging is also also major problem, that battery has to take a lot of time to recharge, and we make this drone for the farmers, so need to make as per as possible to make easy to flying that drone. uh, Drone design, we design this drone for coaxial quadcopter. We be trying to as per as a simple design, and make to low weight. There are the components of the drone. These are the base, arms, landing gears, and motor fixture. Now the analysis part of get go to the Krishna.
Okay, so moving to the analysis part, the analysis was carried out in the software named ANSYS 2023 R1. In the analysis, the only aim was not just to calculate the static analysis, but we also aim to calculate the dynamic analysis, which also gives us some important parameters like how our drone acts under stress distributions, and also the thermal deformations with the change in time. So in agriculture drones, we know there is a payload capacity of 25 kg, 30 kg, and even more. So with the change in time, this capacity reduces as there are sprays which are connected to the tanks, and due to the reduction in the spray or the fertilizers, the capacity reduces. So the dynamic analysis helps in understanding how our drone is going to act under those parameters in reducing capacities. So this is the static analysis when we carried out by our mesh. Initially, we generated a mesh. It was not a fine mesh, but it was a basic coarse mesh with a CFD preferences. So we observed that there was a slight stress formation on the joints of the pipe and the main base plate. So this was not a concerning issue for us, but still Dr. Ankush Sharma guided us that we should reduce the thickness or the uh, material consumption of the pipe, which is also considered as a standardized design of the industries which they use for the manufacturing of these composite pipes. So we reduced our design from 3 mm to the 2 mm, and there was not much variation in the stress formations. So we carried out with 22 mm designs. So why do we choose coaxial configuration over the normal configuration? Like coaxial is already it is very complicated. So it is complicated, but it also gives a better efficiency. If we talk about efficiency, let's consider a octocopter. We have a octocopter with 8 arms, but what if we convert the same octocopter into a coaxial quadcopter? It can also lift the same weight that a octocopter can lift, but with a less material consumption in the arms. Like quadcopter has only 4 arms, and the coaxial configuration with propellers in the same axis, but they rotate in the opposite directions to each other. So it actually cancels the torque. Now the torque is cancelled, so the vibrations are not going to act on coaxial configurations. It will act, but not as much as what normal configurations is. So in coaxial we get better efficiency. The design is compact as compared to the normal or conventional drones. The weight is, we can say the weight is increased in coaxial configuration due to the same axis configurations. So the future scope in our agriculture drone, we try to make a design as such it can be applied to all the sectors. Like there are surveillance drones, there are security drones, and there are agriculture drones. So if we look at the market drones which are available in market, agriculture drones they cannot be converted into surveillance drone or service drone. So we made a design that we can just change the payload capacity. Like in agriculture we have a tank, so we can change it, we can replace it with the for security purpose. As we have cameras, we can replace it with cameras or GPS systems. So concluding with the our one of the best configurations we find out was the coaxial quadcopter, as it was more efficient as compared to other designs that are available in market. Thank you. Any questions?
Thank you. Thank you, PDPU students, for such a wonderful presentation. So it's time for a short break. So we have tea and coffee served in the exhibition hall, and let's meet in a time span of 15 minutes. And may I request the upcoming presenters that from now on we'll follow the international conferences rule, that there will be a presentation of 7 minutes followed by 3 minutes of Q&A.